Hello, I'm Kaini. Today we are going to discuss about a new chapter in mathematics, which is very important, and all this engineering and all the physics and chemistry is using this subject, and that is differentiation, the rate of change and the relation between the variables. How change of one variable affect another variable is one of the most important topics in mathematics, which will be used in all the applications of mathematics in the science, in the engineering, in the banking system, everywhere it is useful. So let us start to do that. Okay, let us start to discuss about the derivative of a function. As we know that gradient of a line, it is not dependent on the points. You can choose any 2 points on a line and find gradient. That means gradient of a line is constant. Look at the diagram here. You can see that if you are going ahead 1 unit on this, the green line, you can see you are going 2 units up. Doesn't matter where you are doing that. You are going 1 unit here. You can see that you can go up another 2 units. So the gradient of this line is 2. That means whenever you are going 1 unit ahead, you are going 2 units up. And you know that the formula for this, m is equal to y2 minus y1 divided by x2 minus x1. That means difference in y divided by difference in x. So this is the gradient of this line. Now, suppose instead of a line, you have a curve. Then what will happen? Let us see. If you have a curve, what will happen? Now, suppose I have a curve like this. Now, look at this curve. Suppose at this point here, at the point A here, I'm going 1 unit ahead. You can see there is a very small change in y, which is going up here. Therefore, 1 unit ahead, it is less than even is 1/10 or 2 millimeter or something like that, whatever. It's very small. And you look at here, if I go 1 unit ahead here, I go up more than 1. Therefore, you can see that gradient of the curve changes at different points. So when you are finding gradient of a curve, that is depend to the point x. So what we should do, how we should find the gradient of a curve. For that, what we are going to do is this. We are going to select 2 points on this diagram. Suppose point A is here and point B is here. Now, if this point B and point A you are having, therefore this is suppose x, and from here, this distance from the point B to point A, this distance, suppose I will call it change in x. Where x was here, I change it to this place. Therefore, this will be x plus change in x. The y coordinate of the point A will be f of x plus delta x. And y coordinate of the point B will be f of x. So if I joined A to B, I am going to get the gradient of this line. The gradient is on change in y, therefore that means f of x plus delta x minus f of x divided by change in x, which is x plus delta x minus x. I can cut x. So this is m of AB. Therefore, m of AB is equal to f of x plus delta x, that is y2, minus y1, which is f of x, divided by x2, which is x plus delta x, minus x. So this ratio will give you the gradient of the line AB, but I want gradient at the point B, So what should I do? I'm trying to reduce the value of delta x. So delta x approaches to 0, tends to 0. Therefore, this gradient of the line approaches to gradient of the curve. That means it looks like a tangent at the point B. A tangent at the point B. Okay, the gradient of that. So in that case, what will happen? This will be limit change of x, delta x, goes to 0, f of x plus delta x minus f of x divided by delta x. Now, you can see that if delta x goes to 0, this will be almost f of x minus f of x, which is almost 0, divided by delta x, which goes to 0. This is also approaches to 0. You have undetermined value of 0 over 0. So what we are going to do, we are going to simplify this. You know how to do this. You have learned about the limit, and you know how to calculate a limit of a function. I'm giving an example. Suppose f of x is equal to x squared plus x. Now we want to find dy by dx. That means derivative of the function. That means how much change in y divided by change in x as delta x goes to 0. Now, what is that? That is dy by dx then will be equal to limit delta x goes to 0 f of x plus delta x minus f of x divided by delta x. So many of you are getting confused when we are saying f of x plus delta x. What is the meaning of f of x plus delta x? You see, when you are having f of x is equal to x squared plus x, you are saying f of 2 is equal to 2 squared plus 2, which is 6. Suppose you are saying what is f of a? You are saying a squared plus a, which we don't know what is the value because we don't know what is the value of a. Now suppose I'm saying f of x plus delta x, means wherever you are having x, you put x plus delta x. That means x plus delta x, a square, you see, a square, whatever here, you have to square it and plus itself. That means x plus delta x. There's the meaning of f of x plus delta x. That means substitute for x, x plus delta x. So here, simply it will be lim delta x goes to 0, x plus delta x, x plus delta x, square plus x plus delta x minus, now f of x, x squared plus x, divide by delta x. Now, we can expand this. We know that how to expand. You know that if you have a plus b squared, what you are going to get? You are going to get a squared plus 2ab plus b squared. So same thing will happen here. If I am going to have x squared plus 2x delta x plus delta x squared. And then I have x plus delta x. Here, you see, always don't forget to put a bracket. Otherwise, you will forget this negative is for both of them. Then you are getting confused during solving the equations. See, here this negative is for both of them. Therefore, it's minus x squared minus x. This is one of the main mistakes you people are doing. This x squared cancel this x squared. This delta x cancel this delta x. So what you are going to get? You are going to get lim delta x goes to 0, 2x delta x plus delta x square plus delta x. Divide by delta x. Yet you can see that if delta x goes to 0, this goes to 0, this goes to 0, this goes to 0, this also goes to 0. Therefore, numerator goes to 0, denominator also goes to 0. Therefore, this part is 0, this part also 0, yet we have not done the limit. What we can do is that we can factorize delta x from the numerator. You can see all of them have got common delta x. I can factorize it. If I'm going to get lim, delta x goes to 0, factorize delta x, I'm going to get 2x plus delta x from here and plus 1. And you can see that there is a delta x here which can be cancelled. So now when delta x goes to 0, this goes to 0, but it remains 2x plus 1. Therefore, the answer is 2x plus 1. That means derivative of the function, rate of the change of y respect to x, is 2x plus 1. That means gradient at every point on the function x squared plus x is 2x plus 1. This is actually finding the derivative of the function dy by dx using first principle. But we know that this is very difficult to go through all this process to get derivative of the function. We have formulas and we have methods which we can do this thing much faster. But we have to understand this is the actual method to find all the derivatives of functions. Now, in next video, I'm going to explain to you how you can find derivative of the function using different formulas. Thank you for watching.